Hello everyone, my name is Logan and welcome back to the lecture hall. For today's video, we will be covering section 11.6, absolute convergence and the root and ratio tests. So, we start with two definitions in a theorem, and this will help motivate the rest of the video. Definition 1, a series, the sum of a sub n is absolutely convergent if the sum of now the absolute value of a sub n is convergent. Now we get another definition. A series is conditionally convergent if it is convergent but not absolutely convergent. So there are examples where certain series, possibly alternating series, may be convergent under one case but not under the absolute value condition. Hence, conditionally convergent. Theorem 1. If a series is absolutely convergent, then it is convergent. So, how is this going to help us? Well, we are going to be doing the root and ratio test, which actually not requires, but it actually brings in absolute values. And so knowing this theorem will help us for the rest of the video because we'll be able to do the tests and know, yes, this will be convergent. Now we have the ratio test. If the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n is going to be less than 1, then the sum of a sub n from 0 to infinity is going to be absolutely convergent. Now, if the limit as n approaches infinity of a sub n plus 1 over a n, where it's all in absolute value bars, is greater than 1 or equal to infinity, then the sum of a n is actually going to be completely divergent. And if the limit of the absolute value of a sub n plus 1 over a sub n equals 1, then our ratio test is going to be inconclusive, where we're going to have to use another test, possibly like the root test, which we will be going to now. Now, onto the root test. So, it's basically the same thing, except what changes? Well, now, it's if we take the nth root of the absolute value of an, or a sub n, instead of comparing the two terms, we're just now taking the nth root of the absolute value of one term, the nth term. If that's less than 1, then the series, the sum from 1 to infinity of a sub n is going to be absolutely convergent. And if it's absolutely convergent, we know it is then convergent. And then if we do the same thing, the limit as n approaches infinity of the nth root of the absolute value of a sub n is going to be greater than 1 or it's going to be equal to infinity, then the sum of a sub n is going to be divergent, basically the same as the ratio test. And our last one, if the limit, the nth root of the absolute value of a sub n equals 0, then the ratio test is going to be inconclusive. So, that is all I wanted to cover for the lecture portion of today's video. Let's transition to some practice problems. Number 9, we have the series -1 to the n minus 1 power times 3 to the n over 2 to the n times n cubed. So how do we do this? Well, we have to use our ratio test. We need to compare. And so we're like, okay, we can do this. So we do a sub n plus 1 over a sub n. So that's going to be 3 to the n plus 1 over 2 to the n plus 1 times n plus 1 cubed. And then that's going to be divided by 3 to the n over 2 to the n times n cubed. And so we then look and we're like, okay, well this is all in absolute values. We take the limit. We know this as n approaches infinity. I'll probably just drop the limits while I'm doing work because there's not much room on the board. And then we know when it's division, we actually have to flip. So that's going to be 2 to the n times n cubed all over 3 to the n, and that's a times now. And so where do we go from here? Well, this 3 to the n is going to cancel with this 3 to the n, and this will just become 3. Or this 3 to the n plus 1 will just cancel to become 3. Same sort of deal with this 2 to the n, and this 2 to the n plus 1 just becomes 2. And so then we see, well, then we get this is equal to the limit as n is approaching infinity of the absolute value of 3n cubed over 2 times n plus 1 cubed. And so now we've seen things like this before. We've compared limits like this before. Well, what's the limit going to be equal to? Well, we just have to look at the highest degree term of the polynomial. Well, that's n cubed on top, and we have n cubed on bottom as well. So then they have the same power. So when it means they have the same power, we just take the coefficients from in front of said greatest power. So our limit is actually going to equal 3 halves, which is greater than 1. So if it's greater than 1, it's divergent, right? So our series is divergent. So we have number 26, and we just kind of stand here looking, and we're like, what do we do? Well, it's the series of -2 to the n over n to the n. Well, when we see something like that where all the terms are to the nth power, we can use the root test, which takes the nth root of said nth power. So how do we do this? Well, we just take the limit as n approaches infinity of the nth root of the absolute value of the nth term, which is -2 to the n over n to the n. Well, we can then say this is going to be equal to the limit of we can say, well, the absolute value gets rid of this -2 to the n, so this just then becomes the nth root of 2 to the n over n to the n, which is going to be equal to the limit of, well, this nth root is going to cancel with that 2 to the n power, and this nth root is going to cancel with this n power over the n. So this equals the limit as n approaches infinity of 2 over n. Well, what is the limit as n approaches infinity of 2 over n? Well, n blows up, right? It goes to infinity. So, and that's on the denominator, so that means it will take our limit to 0. So then we're going to say this is equal to 0, which means our series is absolutely convergent. Which also means it's just normal convergent as well, or conditionally convergent, if we go back to our definition. So this is the last thing that I wanted to cover in today's video. I dance on the pole. I go to class and stuff, and I wanted to incorporate 2 things that I really enjoyed. These are probably my 2 favorite things to do, is math and pole. So if you found it distracting, tell me. If you found it cool, tell me. If there are certain tricks you want to see me do, tell me. Leave them in the comments. Honestly, that felt like a good video. I'm trying to get the YouTube channel moving a little better. So if anybody has any suggestions, let me know. As always, my name was Logan. Thanks for watching. Have a great day. Woo!